they don't. Okay, so now we're recording. Anyway, today we're about halfway through the hydraulic arm project, and we should be at the point where we have got we've put together 3 design options, 3 different ideas, and then we should put together a list of the things that we're going to judge them on. Now, of course, I've given you the requirements for the project, and that should be one of your criteria that you judge by. Does this design completely fulfill the requirements of the project? And then you should also have some other things that we've talked about before. For example, simplicity is a good one in engineering. The simplicity in the design itself, simplicity in the number of parts that it has, that would often be called economy of design. Aesthetics, maybe ease of operation, because in this particular design that the machine that you're designing, you're going to have to operate it. So if it's difficult, if it looks like it's going to be difficult to operate, maybe it doesn't score so well. So you choose what those criteria are that you're going to make your judgments with, and then give each one of them a weight, and then give each one of them a score for each design. Add up your scores to get a total score for each design and choose your best design. And then you should create your final drawing, and all of this, of course, goes into your logbook, just like usual. Same thing. Then we will move on to the prototyping and testing and troubleshooting portion of this, and that will take us into next week, as late as Wednesday. We will have Monday and Wednesday next week to finish this up. And then you will be expected to turn that in so that we can start our CAD training, in which we will learn to use 3-dimensional design tools, particularly Google SketchUp. Now, I can't remember what else I had to say about that project. That's okay. We'll leave it for now. And if we have any other questions, do you have any questions at all about that hydraulic project at this point of the project? You good to go? Okay. Again, if you have any questions, please don't hesitate to email or call or whatever. But we do have our next project is in the works. We are going to do the drone project, and I've kind of decided how I'm going to do this. What I did is I bought several drones. I think I bought 5 or 6 or 7 drones or something like this. And each one of these drones is the same type of drone, and they're all what they call micro drones. So they all can fit in the palm of your hand. They're very, very tiny little drones, but they do have full features. They're a quadcopter design. They have a camera on them so that you can actually control it remotely and see what you're doing, see where you're going, and all that. And they're also designed to work with your Wi-Fi enabled device, like your cell phone or an iPad or whatever else. But so you will need to have some kind of device like that to actually control them. I don't know if they come with an actual controller separate from that. Some of the ones I was looking at did, some of them didn't. And this one, it didn't say if it did or didn't. And so I'm going to assume that they do not come with a separate controller, and that you will have to use a Wi-Fi device of some kind. And then you have to download an app. I think they have it available for Android, Windows, and iOS, so you should be okay no matter what device you're using. And then that's pretty much the nuts and bolts of it. It's a pretty well rated device that gets good reviews on the internet, so I'm hoping that they work out pretty well. But the project will be, quite simply, that before I send it to you, I'm going to break it. I'm going to break particularly the frame of it, so that you have to rebuild the frame and rebuild the quadcopter or this drone around your own designed frame. And I don't want you to just redesign what they designed. I want you to try to figure out a way that you can build a frame that is better, an improved design, either in aesthetics or in performance or in weight. Weight of these things is really quite important. The weight determines how long they can fly, how fast they can fly, and so on. But you will be required to make at least 3 designs that improve something about the original design, and then you will be required to design that design in Google SketchUp, and then you will be required to print that design on a 3D printer, and then assemble it and test it and make it work. This is an ambitious project. It is one of the more ambitious projects I have ever done for this class. And so we want to get started on it on time, right at the beginning of November. And next week, essentially by the end of next week, we want to be started doing our SketchUp. And we want, by the time we get around to Thanksgiving, we should be ready to start 3D printing. Because it takes usually at least a week to get a good 3D print on one of these 3D printers, one of these low-end 3D printers. Hoping in a few years that we'll have a professional 3D printer, but those come at the cost of tens or hundreds of thousands of dollars, and we have to convince the college to do that. It's going to be an interesting thing to convince them of. But we don't have that now, so we're going to have to just use what we've got. So by Thanksgiving, it is our goal to have the design process complete and to be ready to prototype with the 3D printers so that we can test and and troubleshoot if we need to. For the final 2 projects, we're going to do something a little bit different. So the final 2 projects being the drone and this hydraulic arm project. Starting next Monday, you should start putting together a PowerPoint presentation about your project. I would like you to tell us, go through the process. Now that you've got lots of practice going through the engineering process, I want you to do a presentation on the process that you went through and on the success of your project. And it should be about a 10 to 15 slide presentation. It should take about 10 to 15 minutes. And I would like you to go ahead and make that presentation and then record yourself doing that presentation. If you are not sure how to record yourself doing a presentation, I'll show you that now. It's not terribly difficult. You go to PowerPoint and you have a presentation, and you can go ahead and add whatever you want to this. We'll call it title for now, and whatever else, and you can add another slide, a new slide, and here call this one bogus, or whatever, put in a picture, whatever you want to put in. And then you can come up here to slideshow. Let's see if it is actually under slideshow. It used to be. Yep, here it is. Under slideshow, and you can go to record slideshow right here. And you can say start recording from beginning. I'll go ahead and start recording. Now I don't know if this computer actually has a microphone connected to it. It probably does not. But as I'm speaking here, you can see that there's a timer going up here in the top left corner. And that tells you that this is recording. And if your computer is connected with a microphone, it will record your voice. There's even a way for it to record your face, I think, while you're talking, and put a little picture of you in the corner. But I won't necessarily need you to do that. But I do want you to record this, and then when you go to the next slide, it remembers that you've gone to the next slide, but it puts that into the recording, and records your voice over that next slide as you talk about your presentation. So this is one of the things that I would like you to do, is to make a presentation for this project for the hydraulic arm. Included in that project should be, at least on every slide, some kind of image, some kind of drawing, some kind of diagram, maybe a chart on how you chose which was the best option or whatever for your designs. But you should have media on each page in your presentation that helps the people being presented to remember what you're talking about and to be engaged in what you're talking about. Shouldn't just be random pictures, they should be pictures that are very related to what you're doing in the project. But you should also start with a nice, introduction so that people know what you're doing, what the project is about, an introduction to maybe some of the engineering involved with hydraulics. And then the main part of the presentation, probably 2/3 to 3/4 of the presentation, should be all about what you did, what you accomplished, and the things you learned. And then you should end with some kind of a closing conclusion slide that also recognizes anybody who helped you or any resources you used. So it's pretty straightforward stuff, but you should get used to this a little bit. It's something we do a lot in college, but particularly we do it a lot in engineering. And we will do that again when we do the SketchUp. Now on Monday, I will take some time to go through some sample presentations so that as you're getting ready to finish up this project, you can see what good presentations look like and what not so good presentations look like. I do have some of those available from former students and also from other resources. So we will take a look at those. Monday should be about the time when you start thinking about that presentation. So we will do that on Monday. We will also do a presentation for the final project concerning the drone. So, do you have any questions or concerns about what you're doing, what place you're at in the project for me? Uh-huh. That is perfectly fine. In fact, that is actually very good engineering, and so I would definitely say that's good. Yes. It's very good. It's very important to recognize what part of a project is kind of the crux. What's going to be the hard part? What's going to be the more challenging thing to address? And that's what you've done there. And so if you do that, yes, that will definitely reflect well on you as an engineer. Sure. Any other questions at all? You good? Okay, great. Make sure that you do send me any kind of communications that you need to, and go ahead and get started with the final design.